All right, I'm going to help you with the nuclear equations if you are still struggling, okay? We definitely need some reference tables for this. So we're going to need table N, we're going to need table O, and we're going to need the periodic table, okay? So make sure that you have your reference tables handy so you are prepared, all right? So the first one, write the equation for the natural decay. All right, see this? Natural decay. What does natural decay mean? Natural decay means there is one reactant that is going to decay and it is going to produce two different things. One of them is going to come from table O. Other one we figure out by math, and then we have to use the periodic table or table O to figure out what it is. A lot easier if we go through an example. All right, calcium 37. So table N is the first place. So let's find calcium 37. Here we go. Do you see the decay mode? Has a B plus. When we look at table O, we can see that B plus is positron, and here is its notation. So how does that help me? Well, let's go back again. Do you see how they wrote calcium 37, Ca with the 37 up on top? So we're going to start with that, okay? Ca with the 37 on top, okay? And I need a bottom number, okay? So down here, I need a number. See this setup down here? I need something like that, all right? So how do I find that? Well, it wasn't in table O, right? I don't see anything about calcium here. So I go to the periodic table, and that bottom number is the number of protons, or the atomic number. Here is calcium, and you see its atomic number is 20. So we can put this here, 20. So now I have the reactant side finished, draw my arrow. And do you remember what it was? We did mark it. It was a beta particle. I can write it either of those two ways. I'm going to choose the way with an E. So I'll put a 0 on the top, a +1 on the bottom, and then an E. Plus, and here's the mystery. So all of that stuff came straight from the reference table. Now the mystery. So I'm going to set up an equation. And the reason why is I have a number on the top, a number on the top. I'm going to find the missing number on the top, okay? I also have number on the bottom, number on the bottom. I'm going to find the missing number on the bottom, all right? So I'm going to set up an equation. So I'm just going to write this over here. So the top equation is going to be 37. For the arrow, I'm going to write an equal sign, 0 plus, I don't know what it is, x. Okay, well, that should be relatively simple, right? I subtract 0 from both sides, and what is x? 37. And that should make sense because 37 equals 0 plus 37. Perfect. Because remember, this is kind of our divider. The two sides have to be equal. All right, let's try for the bottom number. All right, so my equation for the bottom is going to be 20, right, equals, for the arrow, 1 plus what I don't know, x. Okay, so then for this one, what do I need to do? I need to subtract 1 minus 1 from both sides, minus 1. And then what I get, x is 19. All right, so we're going to write 19. Notice I had number, number, symbol, number, number, symbol, number, number, I need a symbol. So I need to go to my periodic table and find atomic number 19, and that is K. So there we go, there's my symbol. So that is the answer I'd put here for calcium 37. So calcium 37 decays by positron and ends up transmutating into potassium. All right, let's try the next one, cobalt 60. Oh, look, right underneath here, cobalt 60. Ooh, it has a different decay mode. It's this one. So what is that? Right here, beta particle. Remember, that's an electron. All right, so let's write this one. All right, so we have cobalt 60 yields, right? Because it's natural transmutation. I need the bottom number. I need the atomic number. So for cobalt, it is 27. What do I know already? Do you remember it was beta? So that's a 0, a -1, and an E plus, here's my mystery, right? So what I'm going to do is I have top number equals top number plus mystery top number. What do I do to solve for the bottom? Kind of the same thing. Bottom number plus bottom number equals bottom number plus missing bottom number. All right, so let's type it out so that makes sense. So for the top, 60 equals, right, for the arrow, 0 plus x. Obviously, it is 60. All right, let's figure out the bottom. 27 equals -1 plus x. And here is where you must be careful. In order to eliminate the -1, I'm going to have to plus 1 to both sides. I don't know why, but everybody always messes up this one, which means the bottom number is going to be 28. All right, so I have top number, bottom number. What else do I need? Symbol. So I need to look up 28, and that is nickel. Okay, so top number 60, bottom number 28, nickel. That's what gets written here. All right, let's try the last one. Uranium 233. So go to table N first, right? Uranium, here we go. Uranium 233. This symbol. Go to table O. There it is. Alpha particle. I can write it one of those two ways. So I start by writing uranium 233. If you forget, literally the reference table shows you. And notice I'm putting it on this side. It absolutely, you have to write the numbers on the left side. Please don't do it any other way. And that's going to yield, I looked up, it's an alpha particle, right? So a 4, 2, and HE is what I'm going to use instead of drawing the alpha symbol, plus our mystery. Okay, now the bottom number for uranium, everybody always forgets, look down here, okay, 92. Okay, so in order to find that missing one, let's see if we can do it without highlighting. We're going to write our equation. 233 equals, for the arrow, 4 plus x. Okay, so then what do? Minus 4 from this side, minus 4 from this side, and then what do I get? 229 equals x. All right, so my top number is going to be 229. All right, let's do the same for the bottom number. 92 equals, for the arrow, 2 plus what I'm trying to find, x. What do? Minus 2 from both sides, minus 2, and then I get 90 equals x. So that is 90 on the bottom. These two kind of smushed together a little bit. Apologize about that. Now I need symbol, right? Number, symbol. I got to look up 90. Here we go. TH. There's my symbol. So there is that final one. This is the completed answer for uranium 233. Right? Now for this one, when I get down here, I'm just solving for x. So all I need to do, I'm going to use the space over here to set up equations and then put what I found in the blank. Okay, so let's set up the top equation. I first have 9 plus x equals for the arrow always 12 plus 1. Well, okay, so 9 plus x. I got to combine like terms. Oops, typed that wrong. 9 plus x equals 13. Then what? Minus 9, right? Minus 9, both sides. X equals what? 4. All right, now let's do the bottom. We have 4 plus x equals 6 plus 0. Well, 6 plus 0, I'm not going to even finish writing that. It's just 6, right? But I'll write it for you. 6 plus 0. So 4 plus x equals 6. What do? Minus 4 x equals 2. So I have top number 4, bottom number 2. Now I need a symbol. Okay. Easiest thing to do first, let's look at table O. Look at this right here. Beep, beep, beep. I'm going to write that. So I'm just going to put H. All right, there we go. Let's look at the next one. Let's write our equations. Okay. 32 plus 1 equals, for the arrow, 1 plus x. Okay, 32 plus 1 is 33 equals 1 plus x, right? What do? Minus 1 from both sides. 32 equals x. All right, let's do the same for the bottom. 16 plus 0 equals, for the arrow, 1 plus x. 16 plus 0 is just 16 equals 1 plus x. Then what do? Minus 1 from both sides. And 15 equals x. So when we write this, right, we're going to put 32 on the top, 15 on the bottom, mass number, atomic number, and I need a symbol. Well, nothing even close to that on table O, so I need to look up 15 on the periodic table, and look, there it is, phosphorus. All right, now we are on to the next one, okay? And let's set up our equations. So top equation, 75 plus x equals 78 plus 1. Okay, let's combine those like terms. Equals 79 minus 75 from both sides. And what do we get? X equals 4. All right, bottom number. 33 plus x equals 35 plus 0. Well, 35 plus 0 is just 35, right? Minus 33 from both sides. And we get x equals 2. So this one again has 4, 2. So you should remember what this one is. That was helium. If you didn't, we looked at table O. Okay. All right, next one. X equals 208 plus 4, right? X equals 212. What do we do for the bottom? X equals 82 plus 2. X equals 84. So I need what? On the top, 2, 1, 2. On the bottom, I need 84. What symbol? 84. Here we go. Write the correct symbol. All right, last one. All right, top. 12, this one is the most complicated, plus 249 equals 257 plus, do you see that coefficient of 4? 4 times x. All right, now I need to combine those like terms. Okay, so I need to do 249 plus 12. Okay, so that is going to give me 261. Okay, can't do the math in your head, do it on a calculator. 257 plus 4x. Oops, 4x. Minus 257 from both sides. All right, minus 257 from that side. And I'm going to get 4 equals 4x. Well, then what do? I'm going to divide both sides, right, by 4. And I'm going to get 1 equals x. Hopefully that makes sense. And then on the bottom, I'm going to get 6 plus 98. Remember, for the arrow I put equals 104. Oops. Plus x. But not just x, right? 4x. The 4 gets multiplied by the top and the bottom, all right? So combine those like terms, equals 104 plus 4x, right? Minus 104 from both sides. And we get 0 equals 4x. Divide both sides by 4. 0 divided by 4 is still 0 equals x. So what do I write over here? 1 on the top, 0 on the bottom. Check table O first. Oop, ding, 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 right there. It's a neutron. Make sure when you write this n that it is obvious that it is a lowercase n, because this is nitrogen, so don't write that. Also notice for all of my element symbols, capital letter, first letter, second letter, lowercase. This is wrong. Do not do this either. Also, this is wrong. Do not do that either. This is correct. Okay? I hope that helped if you were having trouble.